Hello math students. Sorry I can't be with you right now. Please enjoy this video as we take a look at our lessons on solving. In this lesson we're going to see some equations where we have the same variable on either side of the equal sign. But just like all the other cases where we solve, we generally speaking want to get all of our letters to one side, all of our numbers to the other side, so we can try and isolate one of the unknowns. Our goals today are to solve equations by more or less moving letters to one side and numbers to the other side of the equal sign. We're going to move numbers or letters by doing the inverse or the opposite operation. Truthfully speaking, what we're doing is the same thing to both sides of the equation, but it often doesn't tend to look like that. And then we finally want to check our work by substituting our solution back into the original equation and seeing if the left side equals the right side. So first up, we have this equation we are going to solve for x. We want to check our solution when we're done. It looks like -9 times x plus 8 equals 23. So when I solve, I want to work down the page. I want to keep my equal signs in a column as I work down the page, and I want to try my best to maybe anticipate where some of these terms can go. But in this case, I've got a letter on the left, x is on the left. I've got 23, a number, on the right. So I'm going to move my numbers to the right and my letters to the left. So 23 is a number. We'll keep it on the right. -9x. It has the x term in it, so we're going to keep that letter on the left. And then that +8 there, that's a number, so we're going to subtract 8 from both sides. And when we subtract 8 from the left, it sort of disappears from the left, but shows up on the right as a subtract 8. Again, equal signs in a column as we work down the page. 23 minus 8 is 15. And then on the left we have -9 times x. To undo the multiplication, we want to divide. So we're going to divide this side by -9, and if we do that on the left, we've got to do that on the right as well. Now -9 divided by -9 is going to give us 1. So it looks like we have 1 times x, or 1x, equals 15 divided by -9. So it's a positive divided by a negative, positive 15 divided by -9, so it's going to turn out to be a negative. And then we have 15 divided by 9. Now, that's not going to result in a whole number. It's a fraction. Both 15 and 9 we can divide by 3. So perhaps it looks like 5/3. And I just really want to double check that with my calculator. So I'm going to take 15 divided by 9. Again, a bit of a decimal. Maybe I could press my fraction button and confirm that that is equal to -5/3. So that looks like our solution. X is -5/3. Oops. And what we want to do is we want to check that solution. We want to verify the solution. So in order to do a check, we take the original equation, which was -9 times x plus 8 equals 23. If we think that x is -5/3, then wherever we see x, we want to substitute that value. And I'm always going to substitute in brackets, just so I remember what I want to do, and I don't lose any of the information, and it doesn't look like I subtract or something like that. So on the right is 23. We're going to leave that 23 there. On the left, we have -9 times -5 divided by 3. And you can evaluate that in a bunch of ways, but one of the things we can want to look at is we have a negative times a negative. So this term is going to be a positive. If we do perhaps 9 divided by 3, if I look at 9 divided by 3 here, it's going to be 3. 3 times 5 is going to give us 15, but I maybe want to double check with my calculator. 9 times 5, 45, divided by 3, 15. Okay, looks good. So we have 15, going to carry down the +8, equals 23. And then on the left, we have 15 plus 8 is 23. On the right is 23. So we have something that's true, and that true statement is really just going to confirm the fact that our solution is x equals -5/3. That barking you hear there is my puppy, well, 3 years old now, Luna. I hope that she doesn't get the other dog going, because it'll be really annoying. So what we're looking at today in this lesson are solving equations where we have a variable on both sides of the equal sign. It's really no different than anything else we've done before. It just looks a little bit more complicated. It looks a little bit more intimidating. But generally speaking, we're going to get our letters to one side or numbers to the other side. We're going to talk about collecting like terms, and we're going to need to collect those and then again isolate the variable. So let's review like terms. like terms have the same letter and the same exponent to be a like term. So if we see 3x plus 2x, those are like terms. They're both terms with x to the exponent 1, and it's equal to something like 5x. So if you feel like you got a handle on this kind of stuff, I would really recommend that you pause the video at this point, try the questions, see how they go. Once you've done some thinking on it, play it, and we'll take them up together. If you're not sure, maybe watch me do the first one, and then pause it and try the next one. But it's really important that you try the stuff on your own. Okay, so hopefully you've paused it. Hopefully you've tried it. I'm going to take a look at this first one here. So this equation on the left looks like 3 times x equals 10 minus 2 times x. So I'm just looking at example A here, or problem A here. Okay, so one of the things I want to remember to do is equal signs in a column, and I want to work down the page. I'm going to put numbers on the right and letters on the left. There's no really significant reason why I do that, but if you watch, you'll notice that we'll end up with a positive x on the left. That 3x on the left is a bigger number than the negative 2x on the right, and so generally speaking, if you keep the bigger term on the left, it'll or make that your letter side, you save yourself a little bit of work, but it doesn't really matter. So I've decided I'm going to do numbers on the right. We have this 3x on the left, and what I really need to do is perhaps add 2x to both sides. If we add 2x to both sides, it's going to look like add 2x on the left, but that's because if we add 2x on this side, those two terms are going to add up to 0, and they essentially knock each other out. And as a short form, if we're adding subtracting 2x on the right, we want to add it on the left. So again, equal signs in a column going down the page. Here we have 3x plus 2x. Well, that's 5x. And then on the right, again, is just the 10. Now on the left, we have 5 times x equals 10. So we divide this side by 5. We'll divide this side by 5. And I'm picking 5 because any number that we see in front of x is the number we want to divide off of both sides. And that'll always isolate x for us. And that's because 5 divided by 5 is 1. And so what we're left with is x, or 1x, equals 10 divided by 5. 10 divided by 5 is 2. And I want to check my solution just to be super duper sure. So in order to do a check, we're going to take the equation 3x equals 10 minus 2x, and I'm going to not move stuff around. All that I really want to do is substitute, and I want to see if I get some sort of true statement. So keeping the equal signs in a column, there's the 10, keep the minus 2, but x we think is 2. So here's our x, we think x is 2, so we want to sub it in and see what happens. On the left hand side, we have 3 times x. X again is 2. So on the left, we have 3 times 2, or 6. And on the right, we have 10 subtract 2 times 2. 10 subtract 4. So we end up with 6 equals 6. Well, and that's good because 6 does equal 6. And because 6 equals 6, we have some support, or we have some confidence that that solution, x equals 2, is true. Okay, so if that helps, that's excellent. If you're not sure, jot down your questions. I'd be happy to help. But I'd recommend that you pause the video, try the equation, try problem B here, see how it goes. Of course, if you have any questions, jot them down. But I'd strongly recommend you give it a try. Okay, so I hope you gave it a try. I'll show you what I think about doing this one. Now, I'm going to keep my equal signs in a column. Never going to change that. I'm going to keep my numbers on the right. 18 is a number, so I'm going to keep that there. On the left, we have this negative 4y term. And on the right, we have a negative 5y term. If I add 5y to both sides, it looks like positive 5y on the left now. And by adding 5y to both sides, we've knocked it out from the right-hand side. So this looks like 18. And then on the left, we have 5y minus 4y, so that's 5 minus 4, or 1y, or really just y, equals 18. So again, let's do a check. Let's see if that works out. So we take the original equation, negative 4 times y equals 18 minus 5 times y. Where we see the y, we're going to sub in 18. So we have negative 4. That y, we're going to sub in 18. We'll keep our equal sign, we'll keep this other 18, we'll keep the negative and the 5, and then here's our y is 18. Okay, now on the left, We have 18 times negative 4, so that's a negative times a positive, so it's got to come out as negative. 4 times 18, I want to take a mental guess at it, then I want to check with my calculator. 4 times 18, that's like 4 times 20, so I've got a number that's like 4 times 20 is 80, but a little bit shorter than that. It's not 20, it's 18, so it turns out to be 72. Not bad, not too far off from my estimate. Now on the right, we have this 18, and then we're going to do 5 times 18. So 5 times 18, again, I want to take a mental guess. It's sort of like 5 times 20, which is sort of like 100, but I want to grab my calculator and double check. 5 times 18 is 90. We could take a look at that in a couple other ways, but we always want to double check. Now on the left, negative 72. On the right, 18 minus 90. Again, I want to take a mental guess. That looks like 72 or negative 72, and I want to double check with my calculator, and sure enough it is. So that part is true, and what that really confirms for us is that y equals 18. That solution is true. Okay. Of course, if you have any questions, jot them down. Let's go through them. Now, there are 2 more problems here to solve in example 2. I'd strongly recommend you pause the video, give it a shot, see how they go, jot down any questions, figure out where you get stuck. It's a great place for us to talk and go through the next steps for you. I hope you try them. I'm going to play them, go through them myself now, but please make sure you pause it, try it. Let's see what happens. So for this equation on the left, I'm going to again work down the page, equal signs in a column, and for no other reason than there's a 34 on the right and there's a bunch of x terms on the left, I'm going to keep my numbers on the right, letters on the left. I might just move around a couple things, keep the 3x in front, and then we have a negative 7x. Okay, just moving it over a little bit. And maybe one thing I can do right now, right away, is move over this 18. So I really need to subtract 18 from both sides. And that looks like 34 minus 18. That sort of sounds like 34 minus 20, which is like 14. But let's double check with the calculator. 34 minus 18, 16. Looks good. On the left, we have 3x minus 7x. Those are like terms. They have the same letter with the same exponents. So 3 minus 7 is negative 4. But it's not just 3 minus 7. It's 3x minus 7x. So that turns into negative 4x. Now, whatever is with the x, we're going to divide that off of both sides. So we're going to divide the negative 4 off of both sides. And it looks like we end up with equal signs in a column, of course. X on the left, negative 4 divided by negative 4 is 1. And then we have 16 divided by negative 4. So positive divided by negative is negative. 16 divided by 4 is 4. And we get this solution of x equals negative 4. I want to substitute that in and double check and make sure that I've got the correct solution. As for the question on the right, question B, let's give it a shot. So we'll do equal signs in a column. And if you haven't tried it, pause it, give it a shot, see what happens. Worst thing that's going to happen is you're going to learn something. That's what we're all here for. So maybe I put letters on the left and numbers on the right, and there isn't any really significant reason why to do that, but the 3a is bigger. It's positive on the left. Let's keep it on the left. So here's 3a on the left. On the right is this negative 4. Now I can subtract 2 from both sides. If I subtract 2 from the left, we won't have a positive 2 anymore, but I would need to subtract 2 on the right as well. And similarly, if we subtract 2a from both sides, that 2a term will be subtracted from the right, but it'll also be subtracted from the left. So equal signs in a column. On the right hand side we have negative 4 and negative 2, so that's negative 6. And then on the left we have 3a minus 2a, which really looks like 1a. And right away we have our solution, a equals negative 6. And so it's a good idea to check the solution. We can substitute that back into the original equation and see if we get left side to equal right side. Now in example 3, we're asked specifically to check, so we're going to make sure we do that. I'd strongly recommend you pause it, try the question yourself, see how it goes. If there's anything you're unsure of, anywhere you get stuck, make yourself a little bit of a note, send me those questions, let's talk about those questions. So I hope you paused it, tried it, and you can just double check your work here. Okay, so again, equal signs in a column going down the page. Now this is maybe a more interesting one. I have a positive 5u on the right and negative 2u on the left. This might be a case where I keep the u or the letters on the right and move the numbers to the other side. On the left is negative 8, so let's keep that there. And then I have this negative 2u term. So I'm going to add 2u to both sides, and that's going to knock it out on the left-hand side, and it has to show up on the right. Likewise, this negative 1, if we add 1 to both sides, it will knock out the negative 1 term from the right and show up on the left as a positive 8. So equal signs in a column. We have 5u plus 2u makes 7u. And then on the left we have 1 minus 8, which is negative 7. Now whatever number is with our variable, that happens to be 7, we need to divide that off of both sides. And we end up with a u on the left, sorry, on the right, because 7 divided by 7 is 1. And now on the left we have negative divided by positive, so that's going to come out as a negative. 7 divided by 7 is 1. So the solution for u is negative 1. But let's be sure. So we'll take the original equation again. Let's just jot out that equation. Negative 2 times, let me fix that please. Negative 2 times u minus 8 equals 5 times u minus 1. And wherever we see our u's, we're going to sub in our solution of minus 1. So there's a u minus 1. But we need to keep the negative 2 times negative 1. Carry down the negative 8. Then we have our equals, we have our 5. There's another u again. So we're going to sub in negative 1. And then we're going to carry down this minus 1 again. And then on the left, we're just doing some Bedmas. We have a negative 2 times a negative 1. That's a positive 2. Subtract 8. On the right, we have 5 times negative 1. So that's negative 5 minus 1. And then back to the left, we have positive 2 and negative 8. So that's negative 6. And on the right, it's negative 5 and negative 1 or negative 6. And so this is true. And therefore, that must mean that u is negative 1, that the solution for u is negative 1. So it looks good. Up next is just maybe a reminder that your solutions can sometimes be fractions or decimals. They can just be numbers that are not whole numbers, integers, things like that. It doesn't change anything, okay? Don't let it throw you off if you see a decimal or a fraction. That's just the way that it is. Again, we're going to solve it. We're going to check it. Equal signs in a column. Maybe I do letters on the left. 4x is bigger than negative 2x. So I'm going to leave the letters on the left. So we have 4x over here. On the right, we have this negative 3. Now on the left, we have this positive 1. So let's subtract 1 from both sides. If we subtract 1 from both sides, it'll disappear from the left, but it'll show up on the right as a subtract 3. Likewise, this negative 2x, we're going to add 2x to both sides. So it disappears from the right, shows up on the left. Now on the left, we have 4x plus 2x, which is 6x. And then on the right, negative 3, take away 1 is negative 4. And likewise, or similarly, whatever we have with our x, we're going to divide that off of both sides. And that's because 6 divided by 6 is going to give us 1. And so what we're left with is x equals negative 4 over 6. So that's negative divided by a positive, which is negative. 4 and 6 are both divisible by 2. So 4 over 6 is the same as 2 over 3. And so there's our solution. But let's double check. Let's run through a check. Again, to do our check, we're going to take our equation, 4x plus 1 equals negative 2x, subtract 3. Wherever we see our x, we're going to sub in our solution of negative 2 over 3. So here's our 4, there's the x, negative 2 over 3. We're going to add 1, there's the equals, there's the minus 2, and again, there's the x, which is negative 2 over 3. Or let's check, let's make sure that solution works out. And so on the left, we have 4 times negative 2 divided by 3. So that's a positive multiplied by a negative, so it's going to come out as negative. 4 times 2 is 8. It looks like 8 over 3. And then we have this plus 1 we're going to carry down. On the right-hand side here, we have a negative times a negative, so that's a positive. 2 times 2 is going to be 4, so we end up with 4 over 3. And then we have this minus 3 over here. So we've got some fraction bits, so let's do some fraction math. We have negative 8 over 3 plus 3 over 3. we need a common denominator, so let's make the 1 over 1 the same as 3 over 3. On the right hand side here we have 4 over 3, and we can take that 3 to get a 3 on the bottom. That's equivalent to 9 over 3, because 9 divided by 3 will give you 3, so negative 3 is the same as negative 9 over 3. But now we have common denominators, and we can just look at the numerators. We can look at the tops. So on the left, 3's on the bottom. It's not going to change, but on the top we have negative 8 plus 3, so negative 5 over 3 on the left. On the right, we also have 3 on the bottom. Okay, looks good. And then we have 4 take away 9. 4 take away 9 is negative 5. And there we go. We've got a true statement. So because that's true, that's going to tell us that our solution, x equals negative 2 over 3, is also true. So the solving is something that we do in all of the cycles. It's very, very important. It's one of these really important skills that we want to take with us into grade 10. Of course, if there's anything you're unsure of, please let me know. I'd be happy to help and go over any of the previous lessons. So please make sure you give them your best shot. There's quite a bit of practice. The solutions are available. Don't hesitate to reach out and ask for help. I hope you have a great day.